Alright guys, your essential question for today is how do we identify, evaluate, and add and subtract polynomials? But for this lesson, guys, we're only going to be talking about how do we identify polynomials. Alright, so here's some vocabulary words. Monomial, polynomial, degree of a monomial, degree of a polynomial, leading coefficient, binomial, and trinomial. Alright, a monomial is a number or a product of numbers and variables with whole number exponents. A polynomial is a monomial or a sum or difference of monomials. Each monomial in a polynomial is a term. Because a monomial has only one term, it is the simplest type of polynomial. Now, polynomials have no variables in the denominators or exponents, no roots or absolute values of variables, and all variables have whole number exponents. Here are some examples of polynomials. 3x to the fourth is a polynomial. It's technically more classified, it's a monomial because it's one term. 2z to the 12th plus 9z cubed, that is a polynomial. More specifically, it's a binomial because it has two terms. 1/2 a to the 7th is a polynomial. More specifically, it's a monomial. 0.15x to the 101st power is a polynomial, but again, it's specifically a monomial because it's one term. And then 3t squared minus t to the third is a polynomial, but more specifically, it's a binomial because it has two terms. Here are some examples of non-polynomials. The first one, 3 to the x, you cannot have a variable, an exponent that is a variable. The next one, the absolute value of 2b to the third minus 6b, you cannot have absolute values. The next one, a over 5y squared, you can't have a variable in the denominator. The next one, 1/2 the square root of x, you can't have the square root in order for it to be a polynomial. And then for the last one, m to the 0.75 minus m, you cannot have a non-whole number for an exponent. So those are examples of non-polynomials. Now, the degree of a monomial is simply the sum of the exponents of the variables. So for example, if I give you this monomial, 5x to the third yz to the second, my degree for this monomial would be 3 plus, understood 1, exponent on the y, plus 2, so that would give me a degree of 6. Now, a degree of a polynomial is given by the term with the greatest degree. A polynomial with one variable is in standard form when its terms are written in descending order by degree. In other words, the degree is going down. So in standard form, the degree of the first term indicates the degree of the polynomial, and the leading coefficient is the coefficient of the first term. For example, if I give you this polynomial, notice that it is in standard form because it's in descending order. The degree of the first monomial term is 3, the degree of the second one is 2, the degree of the next one is 1, and whenever you have a constant, that degree is 0. So the degree of this polynomial is 3, and whatever coefficient is with that degree, in this case 5, that is what we call our lead coefficient. Alright, a polynomial can be classified by its number of terms. A polynomial with 2 terms is called a binomial, and a polynomial with 3 terms is called a trinomial. A polynomial can also be classified by its degree. So if its degree is 0, that means you have a constant, or just a whole number, or just a number, a real number. If it's linear, then it has a degree 1. If it's a degree 2, it's a quadratic. If it's a degree 3, it's a cubic. If it's a degree 4, it's a quartic. And if it's degree 5, it's a quintic. Alright, so let's identify the degrees of each of these following monomials. So the first one, z to the 6th, the degree of that monomial would just be 6. 5.6 is just a constant, so its degree is just going to be 0 because it doesn't have an exponent. For C, 8x to the first, y to the third, look at your exponents. There's understood 1 on the x, so add them together, you get 4, so the degree is 4. Look at D, a squared, b, c to the third, add those exponents, so you have 2 plus 1 plus 3, so that degree is 6. Alright, take a look at this one. The degree of A, look at the exponent, would be 3, so the degree is 3. For the next one, it doesn't have an exponent, so the degree would be 0. For C, 5x to the third, y to the second, the exponents are 3 and 2. Add them together, you get 5. And for D, the exponents are 6, 1, and 2. So you add those together, you get 9. Now, as stated earlier, guys, standard form is when you have it in descending order. So look at A. If I wanted you to write that in standard form, the degree of the first monomial is 0 because it's a constant. The degree of the second monomial is 2, and the degree of the last monomial is 1. So this degree is 0, this degree is 2, and this degree is 1. So in descending order, I would put this term first. So if I put that in descending order, I'm going to have negative 5x squared plus 4x plus 3, which means my degree is 2, my lead coefficient is negative 5, There's 3 terms, so we call that a trinomial, and the degree is 2, so I call that a quadratic trinomial. Take a look at B. If I rearrange these in descending order by the degree, I would have 8x to the 4th plus 3x squared minus 4, which means my degree is 4. My lead coefficient is 8. There are 3 terms, so it's a trinomial, and since it's a power of 4, a degree of 4, it's going to be a quartic trinomial. All right, let's take a look at one more slide. For this one, for A, notice if I want to put that in descending order, my biggest degree is 2, so I'm going to have negative 2x squared plus 4x plus 2, which means my degree is 2, my lead coefficient is negative 2. There's 3 terms, so it's going to be a quadratic trinomial. For B, if I put that in descending order, x to the 3rd would come first, and then 18x squared, then 2x, and then negative 5, which means my degree is 3, my lead coefficient is 1. I have 4 terms, so it's what we call a cubic polynomial with 4 terms. And that's it for today's lesson.